So in this video, we're going to start just some preliminary work on graphing a linear equation by plotting points. So we're basically going to make a table of order pairs that satisfy our equation. It's always a good idea to find at least 3 points because we want to make sure that the 3 order pairs, the 3 points, line up in a straight line. And if they don't line up, then we know we've made a mistake. So we have to do some recalculation. So we will plot 3 points on the coordinate plane. And then we will connect the points with a straight line that goes on forever on either end, so we'll put arrows on the ends. Okay, so that's basically the goal. We're going to have just a few examples where we're going to give you an equation of a line, and we are going to construct a table of values and use that to plot the equation on the coordinate system. So let's go to the first example. And so we are going to construct a table and graph the equation y equals 3x minus 2. In our last video where we checked solutions for this linear equation, I reminded you that that form, y equals mx plus b, is called slope-intercept form. Just getting you used to this form for future work. I'm going to explain all of this in a future video, but for now, I just want you to recognize it. That's all. Notice we have a very nice table here with a column for x, a column for y, and then where we're going to put our order pair. And they want us to plot 3 points and check to make sure that they line up. We get to choose the x. So with linear equations, the first column, the x is our input variable. We choose x, but then for the y coordinate, we solve for it. So you get to choose x. You can choose any number you would like to use, but then we have to use the equation to find the y that corresponds to that x. I always like to choose 0. So let's choose x equals 0. I'm going to put my work over here. Y equals 3 times 0 minus 2. And so here we get 3 times 0 is 0, so y equals negative 2. Negative 2 is my y that corresponds to x equals to 0. And the order pair is 0, negative 2. By the way, just a heads up here with the order pair, I will often see my students in their test when I give them this problem, haha, because I do. They will put 0, 2 and not put the parentheses around it. And that is not an order pair. So the parentheses is part of the answer. So don't shortcut putting the parentheses around your order pair, okay? Just a note to you, your instructor will love you. Okay, beautiful. So 0, negative 2 goes here. It's on the y-axis. So actually, see how it is on the y-axis? That we call that the y-intercept of the line. So that's something else that I want you to get used to. The order pair that lies on the y-axis, where our coordinate for x is 0, that's called the y-intercept of the line. We get to choose another x. So let's choose a positive x, and then we're also going to choose a negative value for x, and that way we have a nice representation. I can choose anything. How about 2? So let's go to 2 for x. So now I have y equals 3 times 2 minus 2. So I substitute it into my equation, and I have 6 minus 2 or 4. So I have 2, 4 as my order pair. So let's try one. There's my 2, 4. Okay, it's in the first quadrant because we have coordinates that are both positive. And now let's choose how about if we go to negative 1? You choose x and then you solve for y. So y equals 3 times negative 1 minus 2. So that's what? Negative 3 minus 2, or negative 5. So I have a negative 5 there. So negative 1, negative 5. So I'm coming here, negative 1, and then 1, 2, 3, negative 5. Okay, so do my 3 order pairs line up? What do you think? Yeah, I think we did pretty good. I am going to join those 3 order pairs with a straight line and arrows on either end. Okay, so let me do that. So I tried to get that line to go through all 3 points, but I'm having a little issue with my tool, so hopefully you will do better than I did. But notice how I didn't stop at just the 3 points that I had on my graph. So when I usually give this first test on this chapter for my students, and I ask them to hand draw the line, I will have students who will give me just this little piece right here. I'm going to highlight it from here to here. That's all they give me. And they do not, they're very shy about putting those arrows that go on either end. And the line is infinite, so there's an infinite number of solutions to this line. All those points are lined up. All of those are solutions. And also, I want you to know that this line is made up of a lot of order pairs. I didn't realize for a while that my students didn't get that. So this line just is made up of, hang on, let me show you what I mean by that. So what I mean is that there are all these little points that line up. And that together, when you take all those little dots that are next to each other, just squeezing in there, they then form a line. Hope that makes sense, because some of my students didn't get that for a long time. So there's my solution. Okay, let's try that again with another example. Okay, example 2, we have y equals 3/2 x plus 1. So we are once again encountering here a line that's in slope-intercept form. Slope-intercept form. And we get to pick 3 x's. So we choose 3 x's and then we're going to solve for their y's. And then that's going to create 3 order pairs that we're going to take over to the grid. And we're going to make sure they line up before we draw a line joining all 3 points. Now, that coefficient of x, that 3/2 is a fraction. So that could give us a little bit of challenge, couldn't it? Because it's a fraction. But if you pick your x's carefully, you can be really clever about how you pick your x's. You won't have to deal with the fractions. I'm going to help you with that. First of all, I do think that we should choose once again x equals to 0. So y equals 3/2 times 0 plus 1. So y equals 1. So that's the order pair. It's 0, 1. Which is right here, and it lies on my, let me label those, and our tick marks are 1 unit, okay? Remember, it's good to label the tick marks. And so we have the order pair 0, 1, that's on the y-axis, and as I told you in the last example, that means that this is our y-intercept. By the way, this 1 does relate right to that one that was in the original problem, and that's why we call that form slope-intercept form, because the equation gives us the y-intercept. See that? We're going to be doing some work on that, some more work on that, and just getting you ahead of the game again. Okay, now we get to choose another x. Let's choose a positive x. Again, we have to multiply whatever x we choose. We're going to have to multiply it times the fraction 3/2. So it would be really smart of us to choose x values that 2, the denominator of the 3/2, that 2 goes into. So I'm thinking, great idea to choose like 4. Let's try 4. X equals to 4. So notice what happens when you go to multiply here 3/2 times 4/1 plus 1, right? That because I chose the 4, the 2 is going to go into the 4 2 times, and I'm going to get 3 times 2, 6 plus 1 is 7. So no fractions. To see what we did there? So 4, 7. 1, 2, 3, 4, 5, 6, 7. Right up here. Okay, that's great. All right, on the left side, let's take a negative number. Let's do -2 this time. So we'll choose -2. So again, we're choosing even numbers because of that 2 in the denominator of that 3/2. So that's going to be y equals 3/2 times -2/1 plus 1. And we've got the 2's reducing to a -1. So 3 times -1 is -3 plus 1 is -2. So -2 is my third order pair. So let's see if that lines up. So -2 and down 2. Okay, so those 3 order pairs really line up well. So let's go ahead and join the 3 order pairs in the line, remembering that it's a line that has arrows on both sides because it's infinite. It goes on forever on both sides. So let's go ahead and draw that. So there's my line with the arrows on either side, and every single one of the order pairs on that line is a solution, and there's infinite. Okay, let's do one more. Okay, this next linear equation is not in slope-intercept form. Did you notice? This one is in standard form. This one is in standard form. Okay, but again, we choose x and we will solve for y. Okay, so 0 is always a good choice. So now I get -4 times 0 minus y equals -3. So I get y equals -3, and dividing both sides by -1, I get y equals 3. 0, 3 is our first order pair, and it's on the y-axis, so that is our y-intercept. Okay, now this line also has an x-intercept. How we find an x-intercept is that we set y to 0. So since we have this equation in standard form, I'm going to set y equal to 0 and solve for x. Okay, that would be, let's see what that gives us. Negative 4x minus 0 equals negative 3. So I divide by negative 4 and I'm going to get a fraction. X equals 3/4. So 3/4 0. Okay, so now I have to approximate where 3/4 is, and it's 3/4 of the way between 0 and 1. So I'm going to put a little dot there. And that is our x-intercept. That's not such an easy point to graph, is it? Oh well. Okay, let's see. Let's pick a negative number. Let's pick, how about negative 3? So we're going to pick negative 3, just picking a number, negative 3 minus y equals negative 3. And so here I get what? 12 minus y equals negative 3. And then I'm going to subtract 12. Oh, that's going to be a big number. I'm going to get y equals negative 15. Don't think I have 15, so I better choose something else. Okay, back to the drawing board. How about negative 1? Let's try negative 1. Okay, so negative 4 times negative 1 minus y equals negative 3. So here I get 4 minus y equals negative 3. Subtracting 4 from both sides, I get negative y equals negative 7, or y equals 7. So that's better. We can graph that. So negative 1, 7. So negative 1 and up 7. 1, 2, 3, 4, 5, 6, 7. And it does line up even with that weird 3/4, right? So now let's just join our points in a straight line. So there it is. And one of the things that you might notice is that this line slopes downward, doesn't it? It's on a downhill slope, isn't it? A downhill trajectory, right? And that's going to be something that we will start measuring soon in this chapter, whether our lines are going to rise or fall. And this one falls downhill. Interesting, isn't it? So just wanting you to choose. Okay, the last one. Let's take a look at this guy. Okay, once again we have here an equation, linear equation in standard form. But do you notice something about this linear equation in standard form? About the coefficients a, b, and c? Right? Remember a, let's see, let's rewrite it for a minute. I'm going to rewrite it over here. Negative 30x plus 6y equals negative 12. So I just rewrote it, and just so that we could remind you that a is negative 30, b is the 6, and c is the negative 12. There's our standard form. And I don't know about you, but I noticed that all of those are divisible by 6. They're in the 6 table. So given that this is an equation, it's okay for me to divide by 6. So I'm going to divide by 6 first off, just so that I can get my numbers to be smaller. Okay, so I'm dividing by 6 everywhere. See how all three terms get a 6? And then I'm going to reduce this, and I'm going to get negative 5x plus y equals negative 2. And I am going to use this equation up here, okay? And this is the equation that I'm going to use to make my table, because the solutions to both of these equations, the original one, the bigger equation, and this new one, they're going to have the same solution set. They're going to represent the same graph of the same line. So I'm going to use that just to have our numbers be smaller. Now I get to choose x. Let's start with that 0 so that we can get that y-intercept. The y-intercept is when x is 0. So I will get negative 5 times 0 plus y equals negative 2. So y equals negative 2. So 0, negative 2 is what I've got going there. So that would be down here. So my y-intercept is down here. Then I'm going to choose a positive x. Let's see, I've got a negative 5 to multiply it times. How about 1? Let's just use 1. 1 for x. So negative 5 times 1 plus y equals negative 2. So that's negative 5 plus y equals negative 2. And then adding 5 to both sides, y equals 3. So 1, 3. Okay, so 1, 3 goes here. All right. And then let's take negative 1. I'm trying to keep my numbers small because this graph looks a bit on the steep side, doesn't it? I don't know. Let's see. So I'm going to put the work for this right here. So negative 5 times negative 1 plus y equals negative 2. So that's positive 5 plus y equals negative 2. Subtracting 5, I get y equals negative 7. Negative 7. So negative 1, negative 7, quadrant 4. Negative 1, negative 7, 1, 2, 5, 6, 7. So yeah, these line up, but it's a very steep line. Do you notice that? And it is going uphill. So there's my line. So once again, when we are asked to graph linear equations, we can always make a table of values. We can choose our x's and then substitute the x values into the equation to solve for the correct y coordinate that goes in those ordered pairs. And it's always a good idea to use at least 3 points, because if you only use 2, if you made a mistake with one of the points, you won't catch your mistake. But if you graph at least 3 points and they all line up, there's a good chance that you have done the right work. And another reminder, order pairs have the parentheses around them, so make sure you put the parentheses around your order pairs.